Hello, good day to you. If you're listening to this, that means you're one of my students in statistics and probability. And if you're watching this video, that means you're reviewing after the lesson has been delivered in the class. This lesson is about hypothesis testing, and as a review, hypothesis is an intelligent guess. Usually, you come up with a set of hypotheses that's an alternative hypothesis and a null hypothesis if you're conducting an experiment or if you're having research with experimental design. Now, how do you test the hypothesis? How do you choose which hypothesis to select? This lesson is going to guide you on the statistical process of selecting the hypothesis. There are 5 steps for hypothesis testing. The first and the most important one is to identify the null and alternative hypotheses. It doesn't matter if your design is on point, even if it's good, even if you have the materials, even if your data is sound, even if your statistical treatment is perfect. If your null and alternative hypotheses are not crafted correctly, you might get the wrong conclusion. So the first step is for you to identify what null hypothesis is and alternative hypothesis. Null hypothesis as a guide is usually the hypothesis that says that there is no difference or there is no change. If you're going to compare two groups, that means that one group and another group has no difference at all. That's the null hypothesis. The alternative hypothesis is the hypothesis that says that there is a difference between two groups, or that if we're talking about only one group, that two groups of data for one setup gathered on different time scales, that means that nothing has changed between the two groups. Like if the first group is the initial and the second group are the final data, nothing has changed since. That's what alternative hypothesis is. The second one is, after you have correctly identified your null and alternative hypothesis, the next one is to compute for your test statistic. As a quick review, your assumption is that the test statistic gathered from your limited sample, which is, by the way, should be representative of the population. Your test statistic is assumed to be the closest value that you can get to the population value or to the parameter. So the second step is to compute for the test statistic. This test statistic is going to be used to find the critical value. The critical value is usually, another term for critical value is the p-value. It's the probability under the normal curve. And after that, you make a statistical decision. To make a statistical decision, you compare the p-value to the alpha. And then after that, you summarize the results simply by copying the statement in your chosen hypothesis. For instance, you accepted the null hypothesis. Then when you summarize the result, you simply state the null hypothesis. If you rejected the null hypothesis, that means you accepted the alternative hypothesis. Then in the summary of the result, you include the alternative hypothesis. These are the 5 simple steps in hypothesis testing. To assist you in crafting the null and alternative hypothesis, I'm going to give you 3 examples. I'm going to read to you the problem first, and then afterward, I'm going to show you the hypotheses. You can pause the video and then write down your null and alternative hypothesis and check whether what you wrote is similar to what the null and alternative hypothesis should be. Here is your first example. I'm going to read this, and then after that, you can pause the video if you want before proceeding to the next one, but after that, I'm going to show you the alternative and the null hypothesis. According to the Civil Code of the Philippines, the marriageable age of Filipinos is 18. A researcher found out that the average age of Filipinos who got married is 23 years old. A random sample of 29 married couples were taken and found out to have an average age of 21 with a standard deviation of 1.23. Is there a reason to believe that the sample is significantly younger than the others in getting married at 1% level of significance? So let's try to dissect this first before we continue to the hypothesis. First is, if you notice, the given here is standard deviation. You need to remember that if you're given with standard deviation, that means without question, you're going to compute for the z value. You're going to use the z-test. If you're not given with a standard deviation, you're either given with a degree of freedom or the sample size. If that's the case, then you're going to do t-test, or you're going to compute for the t value. Second is, your alpha is 1%. That means in decimal form, that's 0.01. That will be your alpha, and that's where you're going to compare your p-value. Okay, let's focus on the question at the end. The question reads, is there a reason to believe that the sample is significantly younger? That means, in here, the statement is we're assuming that the value from the sample should be less than others. So others would be 23 years old. It should be less than 23. Okay? So the sample is less than 23. So it should be less than 23. Since it's given here, that means that the other hypothesis that we're going to come up with is less than. It should be less than 23. If that is the case, you know already that we're dealing with a one-tailed computation here. Okay? So let's now come up with the hypothesis. Remember that when we say null hypothesis, we mean to say there is no change or there is no difference. So the statement would be that the mu is equal to 23. However, you need to notice that in the question, we're going to test whether the mu is less than 23. And that means that your null hypothesis, because we're only testing whether mu is less than 23, that means that your null hypothesis should be either equal to 23 or greater than 23. And in mathematics, there is a symbol that combines greater than and equal to. And that's the symbol that we have here. Your null hypothesis is the average age of marriage of the sample is equal to or greater than the general population mean age at marriage. Now, you have two options here. Actually, three. Okay. The first option is, in your research, you can just state the sentence. Just like this. H sub O, the average age at marriage of the sample is equal to or greater than the general population mean age at marriage. Or you can use the mathematical sentence. That's the mu is greater than or equal to 23. You can use either and it will be correct. Or if you feel like it, you can use both. You know, it's not wrong to use both. It feels a little bit excessive, but if you feel like you want to be sure, then you can include the mathematical sentence. As a mathematician, I prefer using the mathematical sentence. Why? It's short, it's easy, and you can't go wrong with it. It also feels cool to include only the mathematical sentence. The alternative hypothesis is based on the question, and the question is what you want to test. So your alternative hypothesis is mu is less than 23. Notice that for null hypothesis, we use the symbol H sub 0 or H sub O, whatever you feel like it. But it's actually H sub 0, if you have the option, you choose the 0. It's a circle anyway, so O looks like a 0. And the second one is, for the alternative hypothesis, it's it's an uncommon practice that's beginning to become common in FIMHS to use the letter A, H sub A, for the alternative hypothesis. But the usual custom is we use a number, and that's H sub 1. That will be your alternative hypothesis. Why H sub 1? Because it's the number that follows 0. H sub 0 is null hypothesis. The next one is H sub 1. But, more and more people are using H sub A, and it's still good. So there you have it. I hope you're correct with your null and your with alternative hypothesis. Let's have the second example. Here are the alternative hypotheses. Oh, here, instead of A and B, we have used 1 and 2. It's okay. Mu sub 1 would refer to the mean of the first group, and mu sub 2 would be the mean of the second group. The assumption is, the null hypothesis is there is no difference in the average scores of the two groups. That's the sentence form. The mathematical form is H sub 0, or null hypothesis, mu sub 1 is equal to mu sub 2. The alternative is, since in the problem, if you remember, we're only going to test whether, if we're going to go back, we're going to test whether there is difference in the average scores of the two groups. So the alternative hypothesis is, when we say there is difference, we don't mean to say just less than or just greater than. We don't just mean to say u sub 1 is greater than or less than u sub 2. We mean to say both. So in the sentence, we use mu sub 1 is not equal to mu sub 2. And since not equal refers to either greater than or less than or both, then we assume that the computation here is two-tailed. Remember, in two-tailed computation, we look for the p-value based on the z-score, and then we double the p-value because we're getting the probability area both from the left and its equivalent to the right. So we're going to double it so that we get the two-tailed value. Lastly, here's the problem. In order to increase customer service, a muffler repair shop claims its mechanics can replace a muffler in 12 minutes. A time management specialist selected 6 repair jobs and found their mean time to be 11.6 minutes. The standard deviation of the sample was 2.1 minutes. At 0.025 level of significance, is there enough evidence to conclude that the mean time in changing is less than 12 minutes. Okay, so let's look at the question. Question says, is there enough evidence to conclude that the mean time in changing is less than 12 minutes? It's clear that the alternative hypothesis is only less than 12 minutes. That means our alternative hypothesis will be one-tailed. Okay, so if the alternative hypothesis is that mu is less than 12 minutes, then consequently the null hypothesis includes both that the mu is equal to 12 and that it's greater than 12. Our null hypothesis says the mean time to replace a muffler is 12 minutes or more. And then the alternative hypothesis is the mean time to replace a muffler is less than 12 minutes. So that's it. That's how you form your null and your alternative hypothesis. You need to sharpen your skill in forming the alternative and the null hypothesis, because as STEM students, you're going to have a lot of quantitative research in the future. Specifically after this semester, next semester, first semester of your grade 12, you're going to begin practical research 2, which is purely quantitative in nature. After that, you're going to have capstone in 3Is, which are both quantitative and qualitative. That means these 3 research endeavors will require you to come up with a set of hypotheses. And without coming up with a correct set of hypotheses, that means that you endanger getting a wrong conclusion or a wrong finding or a wrong interpretation for the result of your research. Now the second step is, the second step is computing for the statistic. The third step is to determining the critical value, and the fourth step is to decide. And how do you decide? Using the p-value approach. The decision rule for the p-value is this: if your p-value is less than or equal to your alpha, to your level of significance, that means there is no way for you to accept the null hypothesis. The only way is for you to reject the null hypothesis. Again, if the p-value is less than or equal to alpha, that means you're going to reject the null hypothesis. If it is greater than alpha, then that means you're going to not reject the null hypothesis. The steps are: you identify the null and alternative hypothesis as a review before we continue. Second is we compute the test statistic. We find the p-value, and then using the p-value rule, we make a statistical decision. If the p is less than or equal to alpha, then we reject the null hypothesis. If it's greater than the alpha, then we do not reject the null hypothesis. If your alpha is less than 0.01, if your p-value is less than 0.01, that means that it's very highly statistically significant. There is very strong evidence to reject the null hypothesis. If it is just within 0.01 to 0.05, that means it's still statistically significant, and there is enough evidence to reject the null hypothesis. If it's greater than 0.05, then there is insufficient evidence against null hypothesis. But be very careful with it. This rule is only applicable to an alpha of 0.05, because usually in research the alpha is 0.05. Now for alpha of 0.01, then it's very strict. It needs to be greater than 0.01 in order for you to accept the null hypothesis. Otherwise, if it's less than or equal to 0.01, you reject the null hypothesis. I think it's time for an example. Let's have an example here. Here's a problem. The LA company has developed a new battery. This is very STEM. its engineering department claims that each battery lasts for 200 minutes. So there's a claim here. That means that the null hypothesis should be, if it's no change or no difference, it should be equal to this claim. Okay? There's already a clue here. In order to test this claim, the company selected a random sample of 100 new batteries so that this sample has a mean of 196 minutes with a standard deviation of 30 minutes. Test the claim that the new batteries run with an average of 200 minutes. The claim to test is that the new batteries run with an average of 200 minutes. Use a 0.05 level of significance. That's the claim. So the null hypothesis is it's always no change or no difference, so that your null hypothesis is that the mu is equal to 200. Since there is no specifics here on whether you're concerned whether the battery will last less or more than 200 minutes, then your alternative hypothesis would be that it's not equal to 200 minutes. The new batteries will last for 200 minutes. Your alternative hypothesis is that the new batteries will not last for 200 minutes. There is no specifics here, whether it's greater than or less than. That means, since it's not equal to 200, that means it's both greater than or less than. That means we're dealing with a two-tailed computation here. Second, we compute the test statistic. If you remember your z, the z value is computed with the following formula: x bar minus mu over standard deviation divided by the square root of the sample size. Your x bar here is 196 minutes. Your mu here is 200 minutes. The number of sample is 100. And your standard deviation is 30 minutes. You plug that into the equation, you get negative 1.33. Use your z table to find for the area under the curve. The area under the curve is the probability of finding this value. Probability starts with the letter P. That's why the probability or the area is also called the P value. But since it's two-tailed, after getting the P value of 0.0918, we multiply it by 2. We double it. The reason for that is in the left tail, the less than tail, we have 0.0918. In the right tail, we also have 0.0918. Two-tailed means we have the same area on two different sides of the normal curve. We simply multiply it by 2. If it's one-tailed, we don't do anything with it anymore. Multiplying by 2, we get 0.1836. I think it's 1836. Some people argued during the discussion that it's 1936, but it looks like it's 1836. It should be 1836. Okay, that's the P value. Let's compare. Your P is 0.1836, and it's obviously way bigger than 0.05. So what we're going to do is we're going to not reject the null hypothesis. That means we're going to accept the alternative hypothesis. What does alternative hypothesis means? That at 5% level of significance, there is enough evidence to support the claim that the mean number of minutes that the new batteries will last for 200 minutes. Null hypothesis is mu is equal to 200. So this is how you phrase it. By the way, you don't just, I think I'm wrong when I say that you just copy the null hypothesis. I think you're going to make a statement like this. You include the alpha by saying at 5% level of significance, and then you say there is enough evidence to support the claim that the mean number of minutes that the new batteries will last for 200 minutes. So that's how you interpret the result. I've also included an additional question here. If you want to answer this, it's really up to you. I'm not forcing you to answer this, but if you do answer this, you can ask me for the answer afterward. Only if you're interested in extending the knowledge that you have in testing hypothesis. I think that's it. Thank you for listening, and I hope you learn hypothesis testing with this short and simple discussion. Always remember that any experimental design, however good the design is, however good the materials are, however sound your your process and your data are, as long as your hypotheses are incorrect, you will always get the wrong result. So make sure that your null and alternative hypotheses are correct before you proceed. That's it. That's it, I think. Thank you for listening. Have a nice day.